digital TV decoders. So those set-top box that you get from your telco, well, from the TV company, if you want to buy a movie or something, the way it works is that additionally with the TV tuner that you have in your set-top box, you also have a built-in modem which talks HTTP or whatever to your TV company, and you can order movies, watch them, etc. It's also known as VOD for video on demand. So the general architecture of a Docsis network, it's really basic. On the ISP side, you've got what's called the CMTS. So it's the cable modem termination system. And it's the way it works is that it broadcasts packets on one frequency or multiple frequency, but that's only for the latest version of Docsis, which can do channel bounding, so it uses more than one frequency to get more bandwidth. It's like 802.11n. For the upstream, it's the other way around. So each modem sends back on a lower frequency, which is usually around 50 megahertz. And this is time division multiplexing, but it's kind of weird because they do funky stuff with the QM, the QPSK, and also well, anyway, it's details you don't want to know. The modem on their side, so they use a time slot, and this architecture can serve from a small neighborhood, let's say 100 person, or more bigger cities. You usually have more than one CMTS in big cities, but for one CMTS you can see like 500 person, maybe more, depends really. I've not seen more than 500 so far. There are two particular things about Docsis itself, is that it was designed in a way to be very compatible with the existing equipments of digital of TV companies. So for example, the actual packets are encapsulated in MPEG payload. So it's just like MPEG TS stream. You can dump it easily, and for example, the repeaters can send them back as well. That's very common. And it uses the same ranges as the TV frequencies. So usually what the ISP do, for example, if you buy internet and not the TV, they put a filter which allows you to only get some specific frequency where the Docsis frequencies are, and they filter out the TV, and that's it. But it's really almost the same, at least for the downstream part. The upstream is a different thing. So that's for the architecture. How does the registration process? So when you boot up your modem, you plug it, what's going to happen? First, it's going to find out where is the Docsis frequency. How to do that? Well, easy. Start from bottom, go to the top. It's going to look at every single step, all the megahertz. And once it's able to tune and it's got some locks, it will check the payloads. And if payload looks like Docsis payload, well, that's it. It's acquired. You got the downstream. Now, to get the upstream, you have to wait so that the ISP broadcasts some Docsis frames with the actual upstream parameters, and then it's going to tune to that frequency with the right timing, the right time slots, and all services, etc. And that's it. At this point, you have both ways established. Then you establish you get an IP simply via the HTTP, send the HTTP request, get the IP back, and that's it, very easy. In that DHCP response, you also have the Tftp server address, and that's very interesting thing here because that Tftp server address contains the configuration for the modem, as in all the SNMP ACL, so who can access the SNMP server on the modem, all the IP filters, what's going to be your upload and download limits, the bandwidth, all this kind of stuff. And also the configuration for the phone system or any other things it may need. So once it's got this, it will apply the configuration, download it via TFTP, and enable IP forwarding. as a general rule, I mean, the modem itself, it's really a bridge, a really stupid bridge, which only forwards all the Ethernet frame that you send on the LAN end to the cable end. And that's useful. We'll see later how we can exploit that. The only filter that there is when it first detects a PC, which is plugged on the modem, it will recognize that MAC address and only let that MAC address pass. So, well, depending again on the configuration, you can have more than one unlimited, but it's usually one. Of course, well, it's not secure, so people thought, oh, what about we encrypt this thing? Which is a good idea, but it's of course not mandatory, so people don't implement it because it's much too overhead, etc. So you'll find lots of cable company which don't run encryption at all, and well, I find it very scary. You'll see why. The encryption, it's called BPI, Baseline Privacy Interface. There are multiple versions of this encryption mechanism. There's BPI 1, in Docsis 1 there's the BPI, which was there just like it exchanged the key over some specific Docsis packets, and then it encrypts the payload. It's triple DES or DS, I'm not sure because the specifications are not clear in that. Sometimes I read it, it's DS, sometimes I read it, it's triple DES. Anyway. Doesn't matter, it's really easily crackable. Also, in Docsis 1.1, they found out that, well, it's kind of easy. You just go with your rogue modem, change the MAC address, plug it on the cable, and that's it. You're connected, and your stuff is encrypted. So they added certificate authentication. So the modems have built in a certificate from the manufacturer. It can also be downloaded in the modem. Via Tftp, etc. However, again, some ISPs, they're too lazy to check their config, and they accept self-signed certificates. So what you do, you create your self-signed certificate, put it on the modem, and boom, oh, connected. Cool. That's nice. So, yeah, they found as well that triple DES, well, it's nice, but it's not really secure. So since Docsis 3, they provide AES. However, AES, it's really computational hungry, so it takes a lot of CPU resource. And for AES, you need a specific chip on the modem to do the hardware encryption. But this chip costs a lot. So, well, the customers aren't ready to pay for something they don't even know about, and ISPs won't deploy it either. So nobody's running AES, actually. For example, Docsis 3, most of the modems right now that you can buy, they don't have AES encryption. It's triple DES only, and that's it. Notice there is interesting part. So, how can we sniff this? Well, let me just tell you the story. I was like trying to debug my TV card and see if I could have it working on Linux. And, well, it wasn't working. And then I decided to try it on Windows. Well, okay, install Windows, blah, blah, it's boring. And, yeah, I tuned to some frequencies, couldn't find anything. And then I tried the modem frequency. And, oh, hold on, I got packets. I got MPEG packets. What the hell? What is in those packets? Interesting. Let's see. So I went on Google, my dear friend Google, and I asked him, oh, what about Docsis specification? And whoa, all public. Ooh, interesting. So I spent a few nights reading those specifications. My girlfriend was very happy. Hi, by the way. And I found out that it's really easy to de-encapsulate. You take the MPEG packets, look at the marker, and put everything back together, and that's it. You get Docsis packets. And in those Docsis packets, it's like a very short header. You got Ethernet frames, and, well, Ethernet frames, that's it. You can use all the tools that you use, like Wireshark, everything. It took me about, like, 24 hours between the time I had the idea. I was like, oh, yeah, let's sniff that. Let's see what's in. And the time I was able to actually read at packets. So, again, it's a really easy thing. Regarding those cards, those DVB-C cards, it's really